Hello everyone. I'm going to walk through another scenario that I recently came across talking to a customer. So typically, when you look at a customer that is using virtual WAN, customer may prefer to have multiple virtual hubs, either deployed in the same region or deployed across regions. That is typically a very common use case for virtual WAN customers to have presence across multiple Azure regions. Now, one of the capabilities in virtual WAN is to provide any-to-any connectivity, which means that any of the virtual networks connected to one virtual hub can also reach out to any of the other VNets connected to remote virtual hubs. Now, in this particular topology, I have two Azure regions, which is again common. So I have Australia East Azure region, and I also have Australia Southeast Azure region. So I've deployed two virtual hubs. They are part of the same virtual WAN. And then I have number of VNets that are then connected to each of the virtual hubs. So I have set of VNets that are connected to my Australia East hub. So these are all using 10.20 prefixes. And then I also have set of VNets connected to my Southeast virtual hub. These are using 10.30 prefixes. So by default, what happens is in this scenario, this VM via the virtual hub can cross to the other virtual hub and then reach this other VM. We don't need to do any configuration. This just works out of the box because of that nature of any-to-any connectivity that is provided a part of virtual WAN. Now, where you might see some complexity is when you start to introduce on-premises connectivity. So if you have Express Route or other connectivity that is landing on the virtual WAN hub, what happens is when you connect to virtual WAN hub utilizing one of the gateways. So if you are doing an Express Route connection, you will provision an Express Route gateway in the virtual WAN hub. And then you will use this gateway as the way of connectivity to your Express Route. Now, when you establish this connectivity, what would happen is you will start learning routes from the Azure side, and also you will start advertising your routes towards the Azure side. So on-premise routes gets advertised to Azure, Azure routes gets advertised back to on-premises. Now, what would happen in a virtual WAN scenario is you will start learning the 10-20 ranges. So that is the routes in my Australia East environment. So you will start receiving these routes back to your on-premises environment. But also at the same time, you will now start to also receive the 10.30 routes also via this same circuit back to on-premises. Now, this is also true on the other side as well. So if you have another Express Route circuit also connected to another hub, you will learn the local routes part of that particular hub, as well as you will start receiving the remote routes as well. So I'm going to duplicate this one here. So you will essentially start learning. So this could potentially lead to an asymmetric routing scenario. And to avoid that is from on-premises, you can use concepts such as BGP local preference to say when you're reaching 1020 prefixes, you prefer this particular Express Route circuit and you reach Azure. And when you prefer 1030 prefixes, you will prefer this Express Route circuit and exit out reaching Azure. So that is the option available today. But I also want to cover another new option that is available within virtual WAN, a feature called Route-maps, which is generally available. So we can utilize Route-maps within virtual WAN to apply a route summarization. So what we can do is instead of advertising individual specific VNet routes back to on-premises, we can summarize our remote routes. So what we can do is we can essentially say we allow all of the VNets that are in the local region flow down through this circuit back to on-premises. But anything we are learning from a remote region, we are going to summarize it via this hub and then send it to on-premises as a route summary. So which means when I want to connect from on-premises to, let's say I want to go to my southeast region, I'm going to follow that more specific path because the specific routes are only learned by this particular circuit. I'm no longer learning those specific routes from the express route circuit connected to my Australia East region. So let's have a quick look at how this can be done. Before that, I also want to demonstrate what are the routes that I learned towards my on-premises environment. So in order to do that, I'm leveraging a Megaport in this instance that is essentially providing me capabilities to connect my express route towards the Megaport cloud router. And then cloud route is receiving the routes that I'm advertising from the Azure side. So when you look at this particular route table that is received by the Megaport cloud router, we can see there are a number of routes that are received. So as an example, we have a set of 1020 routes that have been learned. And also if I move towards here, we have 1030 routes that are received. So these are the routes that we are learning from the remote region. But when we advertise these routes, there is no ACE path prepending or there's no other preferential treatment done when these routes are advertised to the customer. So they are essentially equal routes that are being advertised back to the customer's edge device. So with this, what we want to do is we now want to summarize all the remote routes. So when we are sending traffic from on-premises, we know what is the best path to send that traffic. So anything local would take that local express route circuit, but anything that needs to go to the remote region will follow the circuit in the remote region. So in order to do this, what we will do is we will leverage capabilities with virtual WAN utilizing route maps. So let me go to my hub configuration. So this is my virtual WAN hub. And I have two hubs deployed. So one in Australia East, the other one is in Southeast. So if I look at my first hub, I want to also demonstrate what are the local routes that are learned by this hub. Because when we use the effective routes, we can clearly identify what routes are connected locally and what routes are learned remote. So that's a really good understanding, way to have an understanding around what is local versus what is remote. So you can see here clearly demonstrating anything with 1030 is learned via remote hub, and anything that is 1020, these are learned via the network connection within the local environment. So that's the routes. Those are the routes that learn by the virtual WAN hub. So what we would do next is we will go and create a route map. So I've already created a route map, but let me walk through what is the config of this particular route map. So what we are doing here is we've created a route map. We have a next step conditions. You can either say continue or terminate. But here what I'm doing is essentially I'm looking for any routes that are matching the 1030 prefixes. So I have 1030 /16. And here if you want to match a specific route as is, you can go for as the equal as the criteria, or you can say contains. So the next thing you want to do is what is the action? So if you do match these routes, what do you want to do next? So in my example, what I want to do is rather than advertising the specific routes, I want to be able to create a summarization, and I want to send the summary route via the express route back to on-premises. So that is where I'm going to select route prefix and I'm going to decide to replace this route. So the specific routes are now going to be replaced. So if I switch back to demonstrate, you can see here these are all /24 routes that have been advertised. So these are specific routes that are coming in. but I'm saying anything that is matching 10.30, I want them to be able to summarize and only send the /16 route back to on premises. So that is the configuration of this particular route map. Now, what I want to do is, given the route map is created, the next thing is to apply this particular route map. So when you try to apply the route map, you are applying it against a connection. So in my example, what I want to do is I want to apply it to the outbound connection for the express route. So I want to see in the virtual WAN hub is advertising these routes to the express route circuit. That is where I want to be able to apply the route map. So here what I will do is I will select outbound route map, and then I'm going to select the express route connection. So you can see all the connection types in here. So we have VNet connections and we have express route connection. And you can also see there's nothing applied today. So I'm going to hit save. So this takes a couple of minutes for the route map to be applied. So once the route map is applied, we can come back and see what is the effect of having the route map applied. We can go back to the on-premises equipment and then have a look at the routes to see whether we are learning those specific remote routes anymore, or whether we are receiving the summarized route back to on-premises. Yep, the deployment has completed successfully. So let's come back to the route map UI. Let me hit refresh. So we can see that the outbound connection is applied. So the way to verify what is applied is to go to the route maps dashboard. So this would give us an idea about what are the routes applied in the inbound direction, as well as what are the route maps applied in the outbound direction. So I'm going to select my express route connection, going to select the express route circuit that I have connected, and then I have selected what are the route maps applied in the outbound direction. And we can see here we have the local routes in here, and then this is the route maps summarization we've applied against all of the routes we are learning from that remote region. So this is all configured on the Azure side. Let's now switch back and find out is this reflected on my on-premises devices, and then we should not be seeing the individual 10.30 prefixes flow down to on-premises anymore. So switching back to my on-premises environment, I'm just going to go and refresh this particular instance. So this should now give me an idea as to what routes are being learned by my on-premises device. So we can see here I am learning the 1020 prefixes. So that is all coming through towards my on-premises device from my Azure region. But here we can see we are no longer receiving the 10.30 prefixes from my remote region. Instead, these routes are summarized and sent over to my on-premises device. So this is again, if I go back to the diagram that I had, another approach as to how you can summarize routes that are advertised back to on-premises. Another use case could be if you have large amount of VNets and you don't want all of these prefixes to be advertised back to on-premises. You can utilize route maps to summarize routes that are advertised to Azure side, advertised on premises, or you can also use route maps to apply summarization for routes that are advertised towards the VNets as well. So you can do a number of summarizations and number of route manipulations utilizing this new capability added to virtual WAN.